Today we'll be doing the first lesson from Chapter 4, Divisibility and Factors. We're going to skip down to the definitions to start, and then we'll come up and look at the divisibility rules for each type. So, one integer is considered divisible by another if the remainder is 0 when you divide the two numbers. When we say the remainder is 0, what we really mean by that is that there's no decimal, and that one number goes easily into the other number. One integer is considered a factor of another if, when you multiply, two integers, you get the original number. So like 3 and 4 are factors of 12 because when you times 3 times 4, you get 12. All right, we're going to go back up to the rules. I'll leave it so you can still see that if you didn't finish writing those out yet. There are different divisibility rules for 2, 5, and 10 versus 3 and 9. So make sure that you take note that these are different types of rules. The ones that work for 2, 5, and 10 do not work for 3 and 9. Okay, so an integer is considered divisible by 2 if it ends in 0, 2, 4, 6, or 8. An integer is divisible by 5 if it ends in 0 or 5. So think like 10, 15, 20, 25, 30. Those are all divisible by 5. An integer is divisible by 10 if it ends in 0. So you're counting up 10, 20, 30, 40. All of those are divisible by 10. Even numbers end in 0, 2, 4, 6, or 8 and are divisible by 2. Odd numbers end in 1, 3, 5, 7, or 9 and are not divisible by 2. So on today's homework, you're going to be asked if things are divisible by certain numbers. If it's an even number, you can say yes, because it's an even number. If it's an odd number, then it's not going to be divisible by 2 because it's an odd number, and that will be a statement you can make. When we're looking at the 3 and 9 divisibility rules, they're a little bit different. You cannot do these tricks for anything else. You can only do it for 3 and 9. So, an integer is divisible by 3 if the sum of its digits are divisible by 3. So what that means is, like, if I'm looking at 12, the sum of its digits would be 1 plus 2, because 1 and 2 are the digits in 12. 1 plus 2 is 3. 3 is divisible by 3. So 12 is divisible by 3. Another example of that being 15. 1 plus 5 is 6. 6 is divisible by 3. Therefore, 15 is also divisible by 3. Okay, so those work for divisible by 3. An integer is divisible by 9 if the sum of its digits are divisible by 9. So if we had something like 99, so 9 plus 9 equals 18. 18 is divisible by 9, so 99 is divisible by 9. 18 is also divisible by 3, right? So 99 is divisible by both 9 and 3. All right, let's do some examples. So you're going to get problems like this where it says, it gives you a number, and then it says by another number. So is 1,028 divisible by 2? Yes or no? And then why? So this one is yes, and it's because it ends in 2. Okay, or you could say yes because it's even, right? 1,028 is an even number, or it ends in 8. Why did I write it ends in 2? It ends in 8. Silly Miss Keel. Or yes, because it's even. So since it ends in those numbers, it's going to be divisible by 2. Is 572 divisible by 5? No. Okay, because it doesn't end in, and our rules at the top said if it was divisible by 5, it would end in a 0 or a 5. 572 ends in a 2, not a 0 or a 5, so it's not divisible by 5. Is 275 divisible by 10? No, because it doesn't end in a 0. Up above on our rules, we said it was divisible by 10 if it ended in a 0. Okay, so if it doesn't end in a 0, then that's your answer to why it's not divisible by the answer. All right, page 2. So we're going to do some 3 and 9 examples. So is 1,028 divisible by 3? So first we're going to add up those digits, right? So we do 1 plus 0 plus 2 plus 8, and we get 11. 11 is not divisible by 3. So that means that 1,028 is not divisible by 3. Okay, right? Because we add up those digits, and then from that, we're able to determine if something is divisible. So 522, is that divisible by 9? So we do 5 plus 2 plus 2, and we get 9. Well, 9 is divisible by 9, so that means that yes, 522 is divisible by 9. Okay, so that's going to be a portion of your homework, is using the rules that we learned for the divisibility based off of 2, 5, and 10, as well as using the rules that we learned for 3 and 9. The other part of your homework, you're going to be making essentially lists of factors to help you solve the problems. So, an example of that, Miss Washington's class is having a class photo taken. Each row must have the same number of students. There are 35 students in the class. How can Miss Washington arrange students in rows if there must be at least 5 students, but no more than 10 students in each row? So first we need to figure out what are the factors of 35. Remember that factors, we said, were when you multiply 2 digits and you end up with that original number. So we're looking for 2 digits multiplied together that make 35. So we're going to start with 1, and we're going to say 1 times what? 35, right? 1 times 35 is going to be 35. Then we try 2. Is there anything that we can times 2 by to get 35? No, so we're going to cross it off. What about 3? 3 times anything to get 35? Nope. Nothing for 4. Then we get to 5. 5 times 7 is going to give us 35, right? Okay, now we're going to try 6. 6 times 6 is 36, so there's nothing for 35. And then we stop because we're back to 7, which we already used up here. Okay, so that means that the factors of 35 are 1 and 35 and 5 and 7. Okay, so what you're going to be able to do to show your work is make this kind of a thing on your homework, okay? So for this word problem, we have to have rows that have the same number of students, and there has to be at least 5 students, but no more than 10 students in each row. So it says find the pairs of factors for 35. We have 1 times 35, and we have 5 times 7. That means that we could have 5 rows of 7 students or 7 rows of 5 students to still meet those requirements, okay? To have 35 people and to have them have the same number in each row and have it be at least 5 but no more than 10. All right, so we're gonna do the quick checks. We're gonna do the first couple together, then I will have you pause the video while you guys work on the other ones, and then we'll go over the answers. All right, so 160 by 5. Well, we said the rules for 5 were if it ended in a 0 or a 5. So since this ends in a 0, we're going to say yes. Yes, it ends in a 0. Okay, what about 56 by 10? Well, we said that the rule for 10 was that it had to end in a 0. 56 doesn't end in a 0, so we're going to say no. It does not end in a 0. Okay, what about 53 by 2? Well, 53 by 2, we said for 2s it needed to be an even number, okay, or it needed to end in 0, 2, 4, 6, or 8, and this ends in a 3. So we're going to say no, not an even number. Because your other statement would be no, does not end in 0, 2, 4, 6, or 8. Okay, and then the last one we're going to do together is D, 1,118 by 2. The answer is yes, right? Because it does end in an 8, which is on our list. Or you can say yes because it's an even number. It's an even number. Okay, so you're going to go ahead and finish E through H on your own. Pause the video, and then when everyone in the class is done, push play, and I'll go over the answers. All right, so everyone should have some answers for these. If what you have is different than mine, you're going to want to erase it and fix yours to make sure that they match, because now we're doing 9, 3 3s, and 9s. So 64 by 9. Okay, so we're going to do 64 by 9. So 6 plus 4 equals 10. Is 10 divisible by 9? No. So you can say 10, not, or you could say digits. Let's say digits. No, digits, not divisible by 9. All right, 472 by 3, so we're going to do 4 plus 7 plus 2 equals 13. Okay, is 13 divisible by 3? No. Digits not divisible by 3. 174 by 3, so we have 1 plus 7 plus 4 equals 12. 12 is divisible by 3, so we're going to say yes. Digits divisible, oops, that word is hard for Miss Gill, by 3. All right, 43,542 by 9. Let's see. So we've got 4 plus 3 plus 5 plus 4 plus 2, which is 18. 18 is divisible by 9, so we're going to say yes. Digits divisible by 9. Okay, this one says list the positive factors of each number. So we're going to do 10, well, we're going to do A and C together, 10 and 24. All right, so to show our work for this, you're going to have to find some other room on your notes page here. So I'm going to do 10 over here. To show our work for this, we go 1 times 10, 2 times 5, 3 doesn't work, 4 doesn't work, and then we stop, right? Because we're back at 5, which we already used. So that means the positive factors are 1 times 10 and 2 times 5. When we're writing them out in a list form like they want here, you're going to start, let's change colors. You're going to start at the first number, which should be a 1, and you're going to go down, then you go over and back up. So what I mean by that is I'm going to say 1, 2, 5, 10. So see how I did that? Because I have 1, 2, 5, and 10. So you just kind of make a U shape from your list of numbers. Okay, so let's do 24 as well. So 24, 1 times 24, 2 times 12, 3 times 8. This one has a lot. 4 times 6, 5 doesn't work, and then we stop at 6. So to write our list, again, we're going to start with 1, go down, over, and up. So our list is going to be 1, 2, 3, 4, 6, 8, 12, 24. That one had a lot. All right, so we're going to pause the video here so everyone can do B and D on their own. When everyone is ready, unpause the video and we'll go over the answers. All right, so I'm going to do the work for 21 over here off to the side. So we have 21. 1 times 21. 2 doesn't work. 3 times 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. And then we stop at 7. So our list would be 1, 3, 7, and 21. 31 was tricky. Some of you probably tried a lot of things. I'm going to tell you 31 is a prime number. So remembering that that means that only 1 and 31 go into it. So you're just going to have 1 times 31. And that's going to be your answer, 1 and 31. Okay, the last one is similar to that word problem we did up above. So what are the possible arrangements for example 3 if there are 36 students in Miss Washington's class? When we did it up above, there were 35 students. So we got to start with 36. So step 1 is to make our list of factors. For 36, we have 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 times doesn't work, 6 times doesn't work. Oh no, we already did 6. 6 times 6, sorry. Okay, then we stop, right, because we've repeated 6 and we've already used 6, so that's a little tricky. All right, the rules up above said that we could have at least 5 students in every row, but no more than 10 students. So that means that we can only use, wrong thing. We can only use the 4 and 9 and the 6 and 6, because if we did like 3 rows of 12 or 12 rows of 3, that's not going to work. If we do 2 of 18 or 18 of 2, right, none of those meet those other criteria. So that means that we can have 4 rows of 9. We can't have 9 rows of 4. We can't go the other way because 4 students per row isn't enough students per row. Or we could have 6 rows of 6. And those are the only ways that we can arrange Miss Washington's class that meet the criteria of having more than 5 students, or at least 5 students, and no more than 10 per row. All right, nice job, everybody. That concludes the notes for Chapter 4, Section 1.